Hi, this is Dr. Marshall, and this is the first video in the second part of the structure of physics discussion. And as always, if you're watching this, you've gotten here by going to the home page and then going to the structure of physics assignment, and then you have the participation worksheet in front of you, and you have hopefully clicked on the physics Nearpod presentation, and you're watching the first video. So I'm going to go to the Nearpod presentation, and we're going to... Okay, so we're at the Nearpod lesson, and I've put my name in here, and you're going to join the lesson. And the last version of this, the last part of this, the first part of the structure of physics, we had gotten to the point where we were creating our graphic organizer, and we had created this core of information. Energy gives rise to forces, which gives rise to motion. And you'll hear me say this again and again and again, literally hundreds of times over the course of the year, because this is the essence of physics. And we talked about why that was last time. We showed the relationship between energy and forces and motion. Now we're going to expand this graphic organizer in a way hopefully that makes great sense and provides a really good background for the whole course. Okay, so forces, energy gives rise to forces, which give rise to motion. So we're going to go to the next slide. And so, as before, I'm going to write in the words that go in the blanks here in the notes over here, but I have to type in my email address first so I can send this to myself. academyschools.org. Okay, and the study of motion we're going to call kinematics. And I would ask you why this makes sense. And if you were in class, I would ask you to think about this. Why does this make sense? And the reason would be because the word kina is a Greek word that means motion. Okay, so the study of, or the measurement of motion is what this is all about. And so there are many types of motion we could consider. Some of these are going to be beyond the scope of this class. But initially we'll look at motion outside the context of the forces that cause motion. Remember, we said forces give rise to motion. And you might ask, well, why are we not studying forces, or why are we not studying energy first? We generally are going to study the things that are the easiest for us to understand first. And then once we have a handle on how to describe motion mathematically and in language and other ways, then we'll describe it, or we'll describe the relationship between forces and motion, okay? So this will allow us to develop basic vocab and understanding of the mathematical formulas and graphic representations of motion without the distraction of forces. Okay. So the simplest type of motion we can talk about will be motion that occurs in a straight line. And it might occur to you that that type of motion would also be called linear. So this is linear motion, or motion in one dimension. Okay. This is the simplest case because there's basically only one way to accomplish motion along a straight line. I can either go in a positive direction or a negative direction. I can have something that pushes me forward or pushes me backward. This should intuitively make us think, however, that we can also talk about motion in two dimensions. And We will talk about motion in 2 dimensions. The simplest type of 2-dimensional motion is going to be called projectile motion. And this will be motion where a projectile, an object, is fired from a cannon or shot from a gun, either horizontally or at an angle. Okay, so if you think of motions where something is shot horizontally, so for example, a person running off the edge of a cliff will follow projectile motion. If I shoot a gun in a horizontal way, or I shoot an arrow in a horizontal direction, it will also follow a projectile type of motion. If I kick a football, that's launching a projectile at an angle. So those are all examples. So we go to the next slide. And so I want you to add to your diagram these things. Now, you'll notice that I've inserted a word here between 1-dimensional, 2-dimensional, and motion. So the main type of motion that we'll be talking about in physics falls under this large category of translational. And all this means is that it's something that's moving through space. So if you look down here at my marker here that I'm holding in the where I'm talking from frame, you can see that this marker is moving through space. Okay, so its center of gravity is moving through space. Okay, and that's translational motion. If I went like this, I'm still moving through space. I'm translating through space. On the other hand, if as I'm moving through space, I'm also rotating at the same time as I'm moving through space, that's rotational motion. Or if I'm just sitting still rotating, that's rotational motion as well. So that's a different type of motion, and that's more of an AP physics type of topic. That's a little bit more complicated than what we can get into here. So translational motion means I am translating through space. I am moving through space. And we have 1-dimensional and 2-dimensional motion, and we'll start with projectile. Okay. Now, there are additional types of motions we'll talk about that could be placed under the heading of 1 or 2-dimensional motion, but we can't talk about these types of motion without discussing forces that cause the motion. So things like circular motion or wave types of motions. These are motions that are still translational, but we can't really talk about them without knowing something about forces that cause them. So we'll have to go and talk about forces that cause these types of motions, and then we'll come back and talk about those other kinds of motions. So because of this, we'll usually talk about forces and energy, and then come back to tackle these more complex motions. Now, as we talk about basic kinematics, we're going to develop a set of terms and mathematical formulas and graphs to provide a description of motion. Okay, so we're gonna describe motion every way we can. We're gonna describe it with language. We're gonna describe it with formulas, and we're gonna describe it with graphs. And you may be a little bit nervous about some of the math that's going to be involved, but I would encourage you to keep an open mind here, because I really think I can make it so that this is a lot easier than you might think it's going to be. So some of the terms that you're familiar with because you've seen them in previous math or science classes, we're going to create the terms right now that we're going to use to describe motion. Okay, and these are physics terms, and they're very, very specific to physics, and they'll have meanings that we're going to define in a very precise way, a way that you might not think of. And so these 4 terms, we'll just start with the terms. So 18, the first one is position. And I also want you to try and remember these terms in order, okay? There's sort of an order to these, and I'll explain what that order is a little bit later on, but we're going to try and remember these terms in order, because one of the things that we're going to have to do if we're going to solve problems correctly is capture all of the information that's available to us. And the way that we're going to capture the information that's available to us is explicitly ask questions about all of these different types of information, and I've got to remember them in order to make this strategy effective. So we're going to say position, and then we're going to say displacement, and then we're going to say velocity, and then we're going to say acceleration. Okay, so these are going to be our 4 key terms that we use to describe motion. Let's go ahead and go to the next slide. Okay, now we're also going to have 2 main types of diagrams to help us visualize the process of problem solving. Okay, and we're going to look at one of these right now real briefly, and the other one we'll wait for a little bit to look at. But I'm going to go to another page here to kind of help us see this. I'm going to go to a blank page that I can draw on and illustrate what we're talking about here. And I'm also going to pick the computer up, so my face is going to get a little bit closer to you. Try not to freak out. So on this blank sheet of paper here then, the type of drawing that we're going to be the most used to is going to be something called a motion diagram. Okay, and I'm just going to introduce this to you right now. A motion diagram, very simply, is going to have a place that we're going to identify as the origin, and we're going to identify the positive values, the direction of positive motion. Okay, and a horribly written X there. Let's at least make that a little bit better of an X. So since we're in the X direction here, we're going to say positive values are in the X direction. And we're just going in one dimension here, right? I'm only going either to the left or the right, and to the right is going to be our positive values. And the thing that we're going to accomplish with this is we're going to use this to collect all of the information that we need. Now remember, we said we have position and displacement and velocity and acceleration, and we're going to collect some information. Remembering, normally if I've got a motion, think about this, I've got an initial position, and I'm going to call that x0. My initial position is going to equal 0 meters. I'm going to start at the origin, okay? And we'll be free to define that as our initial position most of the time. It's not going to say that our initial position is somewhere else. Okay? Then we're going to have a final velocity, and we'll just, our final position, and that's going to be x. And let's just say that we don't know what that final position is right now. And then whatever that position is, that will be a displacement. From 0 to whatever that is will be a displacement. But then we also are going to have an initial velocity. And I can say v0, or initial velocity. And let's just say that that's 0 meters per second. And then let's also say that I have a final velocity. And let's say I know that final velocity. And let's say that that velocity is 17 meters per second. Okay, and I'll use a set of arrows that we'll call vectors to visualize that increasing velocity. Okay, so I went from 0 meters per second to 17 meters per second, and that helps me visualize it. And then I'm going to collect an acceleration. And in this case, we're going to say I don't know what the acceleration is. Okay, but the acceleration also has a direction. And in this case, it's going to be in the positive direction. So you can see we're collecting all of this information. And we're going to have to stop this video right now and move on to another video. So I'll complete this discussion of the motion diagram in the next video. But let's go ahead and move on to the next video here.